Y'all know what it is.
Hey there, and welcome back to a very special episode of Eggs. This week, we have guests Dr. Amitava Roy and his associate and Egg Show alumni, Andrew Murphy. Dr. Roy has a background in fluid dynamics, thermodynamics, electrochemistry, development of new materials, and integrated energy systems. In a prior life, Dr. Roy worked for AFC Energy PLC, a fuel cell company listed on the London Stock Exchange as the head of fuel cells, leading a team to develop alkaline fuel cells and system integration. Later, Dr. Roy went on to found his own company, Engas UK, and is currently working for the University of Portsmouth, UK, as a senior lecturer in Renewable Energy Systems at the School of Energy and Electronic Engineering. Andrew Murphy, the man behind our meeting, Dr. Roy, is an award-winning product development, innovation, and business transformation executive and industry expert in the field of hydrogen energy. Joining us today for a discussion about problems and solutions to some of the world's most pressing issues, ranging from the localized production of oxygen for rural hospitals and health centers, and the need for clean cooking fuels in developing nations, to the production and storage of green, solar hydrogen using fuel cells. Please join us in welcoming to the show Dr. Amitava Roy and Andrew Murphy. Hi, everybody. Welcome to the show.
Hello. Thanks for a nice introduction. Hi, everyone.
Absolutely. Pleased to have you here. Well, this is a little bit different for people of our show. You're used to me, Mike, and one other. Today, we've got a little bit of a board. I think just in the interest of time and sort of a succinct introduction, let's just kind of go around the room. Andrew, let's start with you as an Egg Show alum.
It's great to be back, guys. Thank you for having me on a second time. The first time we met, we had a really interesting conversation on hydrogen, just extending that a little bit today with Amit and Prantik. I'm really looking forward to do today's conversation.
Prantik, do you want to introduce yourself?
Yeah, I am the co-founder of Agastya Point Private Limited, and we manufacture inflatable products and which helps to store containment products. Like we work in oil spills, we work in river cleaning projects, and clean energy. We store biogas and even any kind of gas, and we work in the field of aquaculture.
Okay.
Very cool. And Dr. Roy?
Hi, Amit Roy. I have developed a few companies, developed a few innovative technologies, mainly around hydrogen energy. So hydrogen production from water using electrolyzers, fuel cells to use hydrogen to produce electricity and heat, and also hydrogen compression and storage, which is one of those challenging aspects of hydrogen economy. I spent time developing an innovative hydrogen electrolyzer, a compressor, and when I met Andrew about 10 years ago, developing this technology, I have also spent time to develop an innovative biogas upgrading technology to produce bio-CNG or biomethane to solve some of those major challenges that the world is facing around clean cooking and access to fuel, access to energy, that sort of aspects. And this technology can also address to capture carbon dioxide, again, another major area. So take some time to talk about those technologies.
Yeah, of course. No, I think that's incredible stuff. And it's funny, just how isolated we can be in countries like the US and places that are so, I guess, progressive in terms of energy use and stuff like that. We don't realize or don't think about things like cooking oils, for example, or, energy for cooking that, is being distributed in other parts of the world. So I think it's incredible that, you guys are putting this kind of time in. So I guess maybe to lay sort of some foundational work, when we had our conversation with Andrew, we went over a number of these things. So for greater detail on the problem, let's refer you to that episode. But if you can give us sort of a basic understanding of maybe, let's start with sort of our, number one topic, this idea of localized production of oxygen. Let's sort of discuss what is the problem and then how you're addressing the solution.
So this problem of oxygen, probably have heard at various news channels that India is facing a major COVID situation, and supplying of oxygen to the people has been an issue there. India does have lots of oxygen because of steel industries, but supplying oxygen to the people is a challenge because the last mile distribution requires cylinders, etc. So when I was really trying all sorts of different ideas in the middle of the crisis, we came up with an idea to store oxygen in inflatable bags. So I rang up Prantik. So can we use his inflatable products that he currently uses to store biogas, for example, to store oxygen and supply? And we have produced a prototype, and we are going to roll it out, this product in the market. But if I take one step forward, that we need to also produce oxygen locally, and that's where our electrolyzer comes in. So electrolyzer is a technology which takes electricity and water and splits water into hydrogen and oxygen. So here we are saying oxygen is the main target best because looking at the crisis that we are dealing with at the moment, but hydrogen is a byproduct or can be a main product depending on what you are looking at. So it's a great technology which will produce two valuable product or byproduct from water using electricity. And we do that at an extremely low cost. Department of Energy USA set a very ambitious goal back in, I think, 2006, around that time, to set the price of electrolyzers around $300 per kilowatt. Currently, nobody's near there. The cost of electrolyzers that we face today is significantly high. That is the real cost I'm talking about, sometimes over £2,000. Especially for the market segment that we are looking at. The cost could come down at a much larger scale, like 100 megawatt scale electrolyzers, but not many people or not many sites would be able to use that sort of a gigantic scale electrolyzers today because it requires a lot of electricity, it requires hydrogen pipeline to consume. Whereas on the other hand, if you look at the distributed market segments, there are plenty of places where surplus electricity or cheap electricity can be available from renewable sources. But there is no low-cost electrolyzers available on the market which can convert their surplus electricity into valuable product like hydrogen and oxygen to address some of those pressing challenges that the world is facing. Because the main challenge is the capital cost of this electrolyzer, especially in small scale. I'll give you one example. If the electricity is free today, and if you have to buy an electrolyzer from the market, the cost of hydrogen will be almost over £2 a kilogram. And that is purely based on the capital cost of the electrolyzers. And that defeats the objective to displace diesel and petrol. So the current price of diesel and petrol, which has a lot of tax imposed on it, even if we compare on taxed diesel and with using free electricity, hydrogen, we are significantly off the mark to compete against diesel and petrol. So the capital cost needs to come down significantly. Otherwise, we are not going to meet, or at least it will be very difficult to meet the net zero ambitions that many countries, whether it's UK, Europe, USA, and many other countries in the world are setting towards. So the CapEx, capital cost reduction, is one of the key. And that is what I think we have a solution. We have a grant, we have a patent granted. We have a technology to produce hydrogen and oxygen at a low cost. Now, talking about oxygen, for every 1 kilogram hydrogen you produce, you also produce about 7.8 kilogram of oxygen as a free byproduct. And you might say that oxygen is the main product because the market for oxygen is actually much bigger at present than the market for hydrogen. So think a scenario, a rural hospital in a developing country. There's no infrastructure to supply oxygen to those health center hospital. And if we have a solar panel on the roof and a small affordable electrolyzer to produce hydrogen and oxygen using rainwater, we have a total solution that can actually address the key challenges that we face. So we have medical oxygen for the hospital, and hydrogen as a byproduct can be used either to produce electricity using fuel cells or even just to produce hot water. Hospitals need hot water, or even space heating if you are in a colder country. So a solution like solar hydrogen to produce these hydrogen oxygen locally would enable lots of application and business opportunities.
That's really amazing that that technology even exists. And the fact that the hydrogen is a byproduct of the oxygen, what you're really going for is just an amazing benefit that it almost seems like a no-brainer to go down that road and make that happen. Can you talk a little bit about your electrolyzer, the affordability of it, the ease of use, how someone could actually get into this market with you and be a part of it?
Sure. Nice question, Michael. So our approach to this electrolyzer technology is quite different than the technologies. I have a background in doing PhD in this back in 2002 when I came to the UK from India. We built a first of a kind large-scale demonstration project using conventional electrolyzers. So I have the experience over the years to use conventional products that are on the market and then come up with my own ideas. So our technology is unique in the sense that it is almost like a stack-only system. So electrolyzer has different components. So you need to have water source that needs to feed to a system. It's called stack, where you have metal plates, so anode, cathode, where water is split into hydrogen and oxygen gases. And then these hydrogen oxygen gases needs to be purified, processed, filtered, dried before that could be utilized. Now, the cost of gas processing, drying, cleaning is quite difficult, and it has a lot of components we call balance of plant, and it's very expensive. So we have eliminated all of that. All we have is a stack-only system. So a small electrolyzer stack that would be suitable, for example, something like this.
Oh wow!
Imagine this is a stack. So you need to fill water into this. You need to supply your power sources, and you have hydrogen, oxygen coming out. So this is a stack-only electrolyzer system, which is unique in its approach in our planning and designing, etc. So your question would be how you deal with the impurity like moisture, water, and other things from the hydrogen. So we have also developed our own quite innovative compressor technology, and that's where Shell were involved some time ago. So we developed a technology to purify and compress and dry any gases. So it could be biogas, it could be hydrogen, it could be any other gases. So our compressor technology has a multiple functionalities alongside compression. So in a single step, we take raw gas, compressed, purified, and dried. So that helps us to really simplify the conventional electrolyzer technology to reduce the cost significantly. And we believe we are the only company to meet the DOE's targets, Department of Energy US's target in terms of the capital cost reduction. I have not seen any company claiming that, but we have got a product, we have developed a prototype, and along with our stack-only electrolyzer system, plus with our hydrogen compressor, we have a very unique proposition to drop the price down so that we don't actually have to sell that equipment. Maybe we simply go into a business model where we sell our gases, which will really enable our customers to displace their petrol and diesel, because they are not then subject to the high capital cost that the competitors otherwise would have to they normally charge. So we are simply saying that pay as you save. So using our technology, because we can finance it through our investors, etc. So we can produce fuel for our customers, and they can get the environmental benefit to get their carbon credits.
So what are your I guess largest hurdles to implementation? Like, what is it that's keeping people from doing this? So I understand. I mean, I can see, it's night and day how much better this solution is than sort of the traditional or typical stuff. But how do we get that, I guess, to the next step? How do we get this in the hands of people in India or other places that could use the technology?
So we have set a very ambitious goal to raise lots of capital to build a team to work on these and to go into manufacturing. We have done several projects on these. I was fortunate to win a large number of competitive grant funding, research funding from UK government innovation agency called Innovate UK. So we have a successful track record of winning competitive funding and demonstrating and delivering projects. So we have got the technology to a stage that it is now really to grow, really to manufacture bigger units. And it's because it's a modular again, so we could add multiple of these units to make a bigger system. So to answer your question, is fundraising that we are going through. We have put a team together with Andrew and few others. So we are growing the team, raising capital. So we want to really go ahead and push this technology onto people's hand.
Okay.
So, go ahead.
Andrew, it looked like you were going to throw something in there or had something you wanted to add to that.
No, I was just going to give a little background there. So actually, I met Amit about 10 years ago when I was working in the hydrogen team at Shell. And at the time, I was kind of scouting for interesting technologies that could be brought in to bring down, capital costs of these projects. Sort of a lot of good interaction with him at the time around this compressor technology. Unfortunately, it wasn't the kind of correct fit for the big company then, but I thought it was just a fantastic technology compared to what else was out there in terms of cost, reliability, ease of use. Really, that's why I stayed in contact for the last 10 years, and now we're collaborating these days. So there's been a couple of hype cycles, as they call it, in hydrogen in the last 10 years, and it's been great to see Amit's company ride this out because of the technology actually being fit for purpose. And where it's landed now is placed in a really, really interesting position. I think that was what I was really going to say there.
Okay.
That's great.
Dr. Roy, your technology that really sets you apart is the storage and the compression solution and the ease of the small unit and the ability to, the mobility of it is really what sets you apart from everyone else. Is that correct? Am I getting that correct? It's the compressed gas and the ability to compress any gas that's setting you apart and making it available for you to not only collect the hydrogen, but the oxygen for the hospitals and the places in need. Am I getting that correct?
Yes, Michael, I think your understanding is pretty good on this. So what I would say that all the electrolyzer companies out there, they don't have their own hydrogen compressor. They have to buy a hydrogen compressor from another company, and there are not many hydrogen compressor manufacturers in the world. There are more electrolyzer manufacturers compared to the number of compressor manufacturers. Hydrogen compressor is quite a specialist device. And hydrogen compression is quite tricky. Our technology is again very innovative. So for example, if you look at piston type conventional compressor, in order to get to the right kind of storage pressure, so you need to have enough pressure to store hydrogen enough to do your job. Like if you are running a truck or anything, you need to store hydrogen around, say, 350 bar, which is pretty high pressure, maybe up to 700 bar. But conventional piston-driven compressors will need about 4 or 5 stages to get there, and each stage has losses involved. And this is fundamental, really, for any compression technologies, that when you compress any gases, heat will be generated. But we do that we have the capability, I would say that way, we have the capability to go up to very high compression ratio. In a single stage, we may go up to 1:350 bar.
Wow.
Compared to the conventional compressors can go up to 1:10 only. And how this is possible? This is a big, bold claim. How this is possible? The way we remove the heat from compression at the same time when the heat is being generated during compression, we remove that with a very efficient mechanism. We have been funded to actually develop these technologies over the years. So has been gone through due diligence by the UK government innovation agencies called Innovate UK. We worked with several companies as well through these projects. So this sets us really apart from the competition, that we provide not only electrolyzer, stack-only electrolyzer, which is unique in itself, but combining with our unique compressor, we have a total solution to offer hydrogen at a significantly lower cost.
And it can be powered with just a single solar panel.
Yes. So imagine, for example, I would say International Energy Agency just 2-3 weeks ago advised that there should not be new gas boilers in new buildings. And that is again a major sort of advice that we should look into low carbon solution, either heat pump, maybe hydrogen, and hydrogen does play an important role. Currently, you probably have heard whether it's US, Europe, UK, there's a lot of initiative to inject hydrogen into the gas grid to supply to people's home. And then, so initially we're planning to do like 20% hydrogen injection to the gas grid, because grid can handle with 20% hydrogen easily even today. And then the appliances that we have at home, like gas boilers, gas cooker for our cooking, or any other gas appliances, can deal with 20% hydrogen blended with natural gas. Now, the challenge is you have to convince everybody on a single stretch of road to be able to use hydrogen, because it is the same gas main that feeds every houses. It's not like your solar panel or your electric car. You just go and buy your solar panel or your electric car. You don't need to really seek permission from your neighbors for that. Whereas for hydrogen, if you want to use hydrogen, everybody in this house has to be converted, has to believe in it. And if somebody goes to the court saying, is there enough awareness, enough safety in place? So that I see a potential barrier for a quick adoption of hydrogen in people's home. So I'm not against the centralized hydrogen production and distributing hydrogen to pipelines to individual homes. This is still good, needs to be done. But at the same time, there is a massive, large niche market that if you have your solar panel or if you have your surplus electricity via smart grid balancing, then we can, using our technology, we can produce hydrogen at low cost locally and oxygen as well, to be able to use and displace your natural gas consumption in your gas boilers and your cookers. So that is the way we reduce the dependency on the large infrastructure or utilities to actually use hydrogen locally. And if you are in a country where you need also oxygen, because oxygen market is actually much bigger than hydrogen, you might then say, I need my own oxygen rather than buying oxygen bottles. And then hydrogen is a byproduct to keep the house warm and make hot water.
I wanted to ask just one more thing on this particular topic. So you mentioned earlier sort of the ratio of oxygen to hydrogen that is sort of stripped away when you run it through this process. Is there sort of an equivalency there, I guess, in that you could be generating enough energy to then run the equipment like all in one big unit? So you could create your own hydrogen, create your own oxygen, then power the machine with the hydrogen you're creating, that kind of thing. Like, is there such a thing as making it a cyclical process? Because I wonder, especially if you're trying to be, sort of achieve a zero carbon footprint, I imagine transporting the gas and moving things by diesel and that sort of thing, if you're not using it there on site, could actually sort of add to the, environmental cost. And so I wonder if there's such a thing as being totally self-contained that way.
So, yeah, go on.
I'll say maybe I should jump in on that one. So it's a really interesting question, because you start with electrolysis, you take water and you split it apart with electricity to get water and hydrogen. But essentially, if you run that in reverse with a hydrogen fuel cell, you start with hydrogen and you have oxygen normally from the atmosphere, and put the two back together, and you end up again with water and with electricity. So if you have surplus electricity from solar or renewable intermittency, you can store that seasonally or for other purposes. If you have a fuel cell, later when you need your electricity back, you run your hydrogen through your fuel cell and you get your electricity back and recover water. Now, if you've also stored oxygen, instead of having to extract that oxygen from the atmosphere, you can use the oxygen in your fuel cell, which increases the efficiency there. So there are certain circumstances where you would want to have that kind of self-sustained loop of generating hydrogen and then turning that hydrogen back into electricity.
Okay. Yeah, I was thinking in particular, like the application of sitting this outside a rural hospital in India, for example, right? Where maybe it's difficult to truck stuff in and out. It's difficult to store and save and all that kind of thing. I was just thinking if it was possible to set, a temporary unit outside their facility, for example, that was just wholly self-contained, that would be pretty amazing.
Absolutely. And we using our compression technology, the way our compressor works, it actually cleans the gases. It scrubs the gases. So any impurities that is present in oxygen could be scrubbed to medical grade. And this is what we are working on to actually break into this market, into the medical oxygen market, because our compressor technology does allow to enable to do that.
That's amazing. Well, so as we're moving through the show, we decided, we've spent a fair amount of time on this oxygen thing, and I think it's absolutely incredible. But one of the other topics that we brought up at the top of the show was this idea of clean cooking fuel. I think for a lot of people, if you just cook with your, and I think we've touched on it, just quickly with the idea of introducing hydrogen into our natural gas lines. But I wonder, for places, I guess we just don't think about that kind of thing everywhere. So do you mind kind of going into that problem and just how big the problem is that we're trying to address? And then maybe we'll just sort of summarize how that's fixed using your technology once again.
Well, actually, I think the UK has a history with this. I think in the early 1900s, they used a dirtier form of natural gas that people would often use to commit suicide. They would put their head in the oven, and it was the reason. It's a horrible analogy, but I feel like the UK has actually been through this process before in changing from a dirtier natural gas to their current system. And then if they've been through it once, it almost seems like that they could do it again. And, I'm pretty sure Malcolm Gladwell had a podcast about this, and that's where that bit of knowledge is coming from. Yeah. And
so in the UK, we used to have our gas was called town gas, and they would take large amounts of coal and heat it up, and gas would come off it. And the gas was a mix of carbon monoxide, and hydrogen. Carbon monoxide is very, very toxic, so people would put their heads in the oven. So that meant a lot of our gas grid actually was built to be able to cope with having hydrogen in it. So obviously, no one now wants to go back to having any sort of carbon monoxide in your grid, but there is the potential to do a back conversion from natural gas, methane, over to hydrogen. And of course, I think in a developing country context where those grids aren't necessarily in place, you can still use hydrogen for kind of replacing different cooking fuels. So Amit, I think probably you can give me more information on that part.
Yeah, so 2 billion people out there in the world do not have access to clean cooking fuel. I did a project recently in collaboration with the University of Surrey here in the UK, and that was under the Global Challenge Research Fund of the Innovate UK of the UK government. We did this project for 2 African countries, Ghana and Uganda. We looked at these challenges quite closely. That who is affected by these, the women and the children who spend a long time exposed to these heavy indoor air pollution in smoky kitchens. So firstly, they spend a lot of time in collecting sometimes firewood and then using very inefficient oven or open pit to cook and spend a long time. If we can address that problem really with an efficient modern cooking solution, we're going to improve the productivity of masses. A large number of population are just not really taking part in a productive manner because they spend a lot of time in the kitchen. That affects the health, the eyesight, and a lot of death associated with the indoor air pollution. It has been recognized by UN as well and large organizations, so that we need to address clean cooking challenges. And 2 billion people is not a joke. So how to do that? Using biomass or waste, organic waste, which otherwise would rot and methane would naturally come out and add to the global warming problem. But if we can deal with these organic waste to convert into biogas, so like bacteria will convert into biogas under an anaerobic digestion process. But what we have done, we have developed a simple technology using our compressor, in fact, using our compressor technology to purify raw biogas into biomethane and biocarbon dioxide. So biomethane and bio-CO2, two valuable streams. And then we bottle biomethane in cylinders to enable people to cook, and that would be almost like your LPG cylinder. LPG is liquid petroleum gas, which is like propane or butane, some people call that way. So biomethane stored under high pressure can provide the same benefit, but in a completely sustainable manner. So not only we're solving the clean cooking challenges, we're also solving the sanitation and the waste disposal problems as well, but at the same time capturing the carbon dioxide. Carbon dioxide market is massive, because there's a lot of legal targets put on companies to reduce the CO2 footprint. So this technology actually enables companies to adopt and support. It's a perfect circular economy type solution, because carbon dioxide, the biocarbon dioxide, is not a fossil carbon dioxide and captured from raw biogas, because raw biogas has about, say, 55%, 60% methane and about 35-40% carbon dioxide. So we capture that carbon dioxide. We can feed that carbon dioxide into greenhouses to produce more crops, more vegetables. In the UK, there are farms, they buy carbon dioxide to grow their tomatoes and other vegetables faster. So it's a really valuable. I bought carbon dioxide the other day from a supplier, and it costed me about £35 a kilogram, significantly more expensive. So this, using this technology, we can convert raw waste biogas into two valuable byproducts. One is biomethane that can be used for clean cooking, but also you can run your gas vehicle as well, or your tractors. I sold a few plants based on this technology here in the UK and in India, to be able to produce fuel for vehicles. But at the same time, you can use this for your clean cooking as well as electricity generation using natural gas gensets.
Okay, so there's a lot to unpack there. The first, capturing the biomethane in the first place. I'm sure setting that up to begin with in a landfill, or I've seen here in the States a few landfills that are designed to capture the gas and reuse it. It looks like quite the investment and quite the solution. If you're going into a third world country like, Ghana or places like that, and you're trying to implement something to capture that gas in the first place, is that one of the major hurdles that you have to overcome in developing this? Or does your compressor the actual capture process seems like the hardest part of that? Is that correct, or am I off on that?
Yes, so there are large companies. I would not drop the names. Large companies, massive companies who are in this sector to produce biomethane in large-scale centralized plants. The cost of these plants over £1 million, maybe few £1 million. So they are suitable for the UK, European markets, US markets, where you have large-scale centralized digesters, biogas digester, where food waste or farm waste could come in a centralized place where you produce lots of biogas, and then you purify using this conventional standard industrial size equipment to separate methane and carbon dioxide. But in developing countries, where do you get a large amount of feedstock? Because feedstock is a challenge, because somebody will simply cut the supply chain of feedstock and then risk your investment completely. So there's a need for farm scale solutions. So whosoever is generating their waste is not a lot of waste, but a small amount of waste, to be able to utilize it to produce their own fuel and fertilizer. There is no technology in the market. We have been really operating in this space. Our technology has actually a product that we sold, and a lot of interest in this product, to be able to go into a minute scale. It's modular, again, we can make bigger, to be able to convert a small amount of stranded biogas or the biogas or landfill gas, which is being flared otherwise, can be converted into these bottled biomethane for multiple usage, either for clean cooking or power generation or for refueling of vehicles. With my background in fuel cells, I spent a long time developing fuel cells at AFC before. So bio-CNG can also be used in solid oxide fuel cells to produce electricity even at a high efficiency, and that is a silent power. Like engine will make some noise when you run it, but in a domestic setting, if you have a solid oxide fuel cell, they are perfectly suitable to use this bio-CNG.
Okay. So, I mean, I guess another one of the problems might be the canisters. I mean, is this the type of technology that you would use the inflatable canisters for as well?
Probably not. We'll go with the standard that is approved by the regulatory bodies. We'll go with the high pressure cylinders to store enough gas so that to minimize the distribution and handling of the gases. If you are on the same site, like if you have a biogas plant in your farm, my uncle has a small digester back in India that I remember 40 odd years ago. It does produce all the fuel for all the cooking in the kitchen for the past 40 years. It works perfectly. You don't need to really pressurize it. So it feeds to your kitchen, so 100 meters from the main house where you have the farm, and it feeds through a small plastic pipeline into your kitchen with some minimal purification. You have your cooking fuel there. But if we can add a biogas purifier unit that we have developed, we then can actually compress and store. So any surplus gas, which otherwise cannot be stored, can be saved for later. So when you have guests in the family, then you don't have to run out. You still have something stored.
Okay.
Well, and you also say too that, I mean, this is clean. How clean is clean relative to, I mean, when we're talking in interior pollution, and that sort of stuff going on in the house, how much cleaner is the bio CNG versus, the traditional stuff?
In the UK, we have a very strict regulation to meet the requirement of the gas grid specifications. We have national grid specification there. And we sold our gases here to refuel Mercedes Sprinter vehicle here. So we actually certified that the product is suitable for vehicle fuel as a vehicle grade fuel, which has the stringent requirement. So once you meet that sort of vehicle grade fuel requirement, that is going to support any other usage, really, whether it's for fuel cell usage, consumption, because there's no carbon monoxide in there. There's no very, very little hydrogen sulfide, which is less than the tolerance level that a fuel cell would accept. So it is actually very pure, same gas quality that you get in the UK's gas mains.
That's incredible. I was wanted to go back and talk about the electrolysis process in the smaller city areas, kind of like in India and Ghana, and places where water is actually an issue. In some areas, you just can't get clean drinking water. You can't get, there's just no access to it. Having a machine like yours and the ability to create the electrolysis process, and Andrew, you said you could actually convert it back to water. Could that maybe come back to a solution that could also provide water for these remote locations? Is that a thing? Am I completely off base there?
If you have if you require water in your electrolysis, thinking Amit can talk about the water purity you would require. But then if you are transporting your hydrogen or even using it locally in a fuel cell, you will be generating 100% clean water from your fuel cell. Sometimes it will come out as liquid water, sometimes it will come out as steam. But in those locations, if you are generating water, and it's very pure water, you can always find a use for it. I think, Amit, maybe you can comment on the kind of water purity you need for the electrolysis side.
So before going there, so how much water is needed to make 1 cubic meter of hydrogen? So we need only 1 liter. But Michael, I totally address your point that water is important, more important from a drinking point of view. So we have to meet the drinking requirement first before thinking about hydrogen and oxygen. So I totally buy that. If you have a mechanism to collect rainwater, which is already very pure, then that should be utilized to produce hydrogen and oxygen. And we don't need really a lot of water at all to make hydrogen. So 1 liter water will produce 1 cubic meter, which is 1,000 liter of hydrogen, and 500 liter of oxygen from 1 liter. So that obviously solves other major challenges, oxygen and hydrogen together. And if you have to combine it, like if you are burning hydrogen to produce heat or electricity, you're going to recombine into water. If you collect that water, that is already ultra pure. So instead of then waiting for the rainwater, just reuse the water again and again. So you're not actually drawing a lot of water. If you can reuse the same water back into the electrolyzer, so the only thing you are bringing into the system is the primary electricity from your solar panel.
So it's 100% renewable. So you could, you could have 100 gallons of water in a tank that just keeps going through the system over and over again, generating the hydrogen and generating what you need. You just capture the steam again. Sorry.
Yeah, there will be some losses. So I would not say it will be 100% efficient to capture the water. There will be some losses, some evaporative losses, because when you are moving from hydrogen to oxygen and storing in cylinders, there will be some losses. But the concept is that the water could be recycled back, but not the electricity, because then it will become a perpetual machine. Obviously, that would defeat the purpose. It doesn't exist. So electricity is the primary energy, and hydrogen is the only energy carrier. So it's a secondary form of energy. It's a storage mechanism. So the primary energy has to still come from solar, etc. But the water is a mass that could simply change its form into liquid water, into hydrogen, oxygen, and then back into liquid water.
That's it's so neat. I just love that this technology is out here, and there's people like you guys working on it and driving this forward, because it's definitely something that needs to be addressed, and definitely something that more people need to know about.
One thing I would say, Michael, about the clean cooking, we talked about biomethane and bio-CNG for clean cooking, but what about solar hydrogen cooking? Again, that has a really massive opportunities there. This is a small hydrogen cooker, very small. It's like a camping stove. But there are other one, much nicer looking one, catalytic burner type ones. There are different types of hydrogen burners out there. So because then the problem becomes even simpler. So think about a biogas plant. You have to collect the waste. You may have cows in the shed, but you still have to feed the digester. It requires somebody to get involved to run the plant. And sometimes people are not interested or do not have the time to do the biogas plant, because it's a little bit of manual handling is involved, which is great because it solves sustainability problems, sanitation problem, etc. But if you have a solar panel and a small electrolyzer, the one that I was showing earlier, that would become just like your solar battery sort of fixed installation. You don't need to really do anything. So you have your solar panel on the roof, electrolyzer outside in a box in the garage or in the garden with a few cylinders to store there, which will feed a pipe, stainless steel pipe, fully welded, so no joints, into your kitchen using a catalytic burner. So there's no flame that you can see. No way hydrogen could leak. So have a solid, really welded catalytic burner, and you cook your food. So that is the system which has a very little handling, day-to-day handling. And I believe there's a massive potential to offer a small, portable, low-cost electrolyzer with a small compressor to enable this market opportunity.
Do you have an idea of how much a system like this would cost for someone who wanted to get into it and purchase an electrolyzer and a compressor system? Is it affordable for an everyday user, or is it something that, a small hospital has to get, or can a small family?
Very good question. I believe everybody will ask this question. So I would say that our business model is not to really sell initially, to actually sell gases. So you would give the equipment to the people to use it. And so as you save your conventional fuel, and then you pay to us to make it really easy. So we can actually reap the rewards long term rather than selling our equipment for one-off low cost. We want to sell fuel. and an oxygen. And that is the business model. It's a win-win, I believe, from us to develop and invest, to develop the technology, but to reap the reward over a long period of time. At the same time, our customers will get a technology that we look after for them, but provide clean fuel and oxygen as well.
I actually really like that, because the average person who gets a system like this wouldn't necessarily know how to maintain it or necessarily know how to install it in the first place. And whereas if you're providing it to them in exchange for the gas products or a portion of it, that solves both of those problems. And I like that a lot. So, well, we're almost getting.
So effectively, we're offering a service.
Yep. I think I'm dropping out here. Anyways, Dr. Roy, thank you so much for your time. We really appreciate you coming on the show, and Andrew and Prantik. Really appreciate you guys coming back and talking about this. Can you tell people where they can go to find out more about your product, how they can maybe reach out if they're interested in learning more about what you do? Is there a website they can go to?
So yes, so we are building a new website, but I will mention the website here. It's www.en, so energy November hyphen, like that's in the middle, gas, GAS, like oxygen gas.com. So www.en-gas.com.
Okay.
That's great. And if people want to reach out to you directly or anybody on the panel, would you guys like to share your information? Otherwise, we can just put it in the show notes.
Absolutely. We're very happy to talk to whosoever is interested, have more questions about to get involved with us.
Excellent. Okay. Well, we will share then LinkedIn information for everybody in our show notes, as well as the link to Engas. Anything else, Andrew? Anything you'd like to share before we get out here?
No, thank you again for having me on the show. I enjoyed being here, talking about hydrogen again. In case any of the viewers do want to reach me, my email is andrewmurphy@hcimzadi.com. Feel free to drop me a line anytime. I have my own hydrogen consultancy, HC Imzadi, which you can find as well. Always happy to receive questions.
Yeah. And I'll give my email ID if you also need that, which is aroy, so Alpha Romeo Orange Yankee, @en-gas.com.
Okay.
Great. And Prantik, would you like to share your business link or how people can learn more about your inflatable products?
Yeah, thanks for involving me today, and it was a great honor in being associated with you. In case you want to contact me, you can contact me at the email ID Prantik, PRANTIK @Agastya, AGASTYA.in.
Very good. Well, cool. Well, thank you all so much for doing this. This has been kind of an exciting episode of the show, having this panel of people who are much smarter than Mike and I here. And so it's always a pleasure to talk to people like you guys that are just doing amazing things for the planet. We're happy to share your message and grateful for everybody who will tune in and hopefully do something to get involved.
Thanks for having us.
Michael, nice. Sorry, Andrew, that was brilliant. Thanks.
Yeah.
Absolutely. And thanks so much to everybody who tunes into the show this week and every week. And we'll see you all next time.